All right, just playing around. You know, I got to have my fun. Hey guys, so update on donations. People that give me donations. You've actually, with your donations, that went to. I'm looking at the camera. I'm thinking it's there. It's here. It actually went to your donations. A handicap ramp. Guys dying of cancer, and you can pick them up in your hands. It's well, they wanted me to build a handicap ramp to help them. Trying to look at this lens here to help them with their to help them. It's weird looking at the camera and seeing part of my face. To help them, you know, transport him in and out of the building. So I built the ramp all for free. I donated, you know, what I could, and you guys, the money you gave me, donated the rest. So your money that you've been giving you guys, what goes to that? Now let's go ahead and start this broadcast. Let's see, screen share screen. Here we go. Share screen. Oops. Here we go. Oops. 3 watching. I get to talk to you here now. And chat should pop up, I would think. I'll try a hello. All right, 5 watching. Hello, hello. Oh, there we go. There's my chat. So hello. First thing I'm going to do then is get you guys this link. And copy the link, and I'm going to drop it over here. Here's your link. Link for release, for NTSB release. And then we're going to basically stroke my ego with this. Because we're going where'd the darn video go? Nope. And I'm in the next one. So is this one? Yep. All right. So we're going to show that I did this video, September 16th. And we had an open forum. We discussed this whole deal where I said the regulator, I've got this marked off with some things here. Let's go back to there. I have it marked off with a timestamp on my notes here. This is a regulator we're talking about. Not this regulator, but a regulator like this that will get you your you tell you what's going on with the meter, with the gas flow. And now let's go to the NTSB release. It's 1 of 7. You guys have a copy of it over there now. And let me see if I got to say hi to anybody. Nope, nobody to say hi to. Okay, so it's 1 of 7. And jumping right to it, here's the report. This is just background, the age of the pipe. But this right about here picks up. On September 13th, prior to the overpressure event, so prior to the event, a Columbia Gas contractor work crew, which included a Columbia Gas inspector, incidentally, executed one of the Columbia Gas design and approved pipe replacement projects at the intersection of South Union and Salem Street, cast iron distribution main. Here we go. The distribution main that was abandoned still had the regulator sensing lines that were used to detect pressure in the distribution system and provide input to the regulator to control the system pressure. So once the contractor crew disconnected the distribution main that was being abandoned, so disconnected it, the section containing the regulator sensor lines began losing pressure. So the regulator was on an abandoned pipe. So let's go to this. The regulator, and where are you? Here. This regulator, this pipe is abandoned. There's the new gas flow pipe somewhere else. There's supposed to be a primary and a secondary, but for some reason we only talk about regulator, and I was triggered on that by the video I put here with NTSB saying regulator. I'm like, where's the secondary? Where's the primary? We're talking one regulator, and I mentioned how I was triggered in this video. And this is what you'll see I stated back then, that I said that I think when they changed the pipes, and you'll see it in this video, that they left the working regulator, and now it appears there's only one regulator, on an abandoned pipe. The abandoned pipe no longer has pressure in it. It then sends the message back to the control board, if you will, to increase pressure volume in the new working pipe. The new working pipe releases it keeps going up and up in pressure as long as this keeps sending a message saying, "Hey, we don't have we don't have flow." So it keeps sending it. This flow just increases from the pressure and keeps your pressure regulator, right? Increases from the existing pipe, blowing out all of the home regulators, the pilot lights. Let's see if they actually mention the pilot lights. I didn't read the pilot light part. The pilot lights were being blown out by this high pressure. Let's see. Once the contractor crews disconnected the distribution main that was abandoned, the section containing the regulator sensing lines began losing pressure. Of course, it began losing pressure because it no longer has pressure. Let me do this. Let me correct that. It loses pressure only if there's leaks in the pipe, and there's plenty of pipe leaks in the pipe system. Otherwise, it wouldn't lose pressure. It would just be status quo. It would look like nobody's asking for gas. Losing pressure looks like they need more gas. So the regulator had what, a zero, what do they call it? Zero meter reading, and then there's a dead meter reading. And so I guess this would be a dead meter reading. Let me get that wrong and backwards, but I don't want to go down that track. At the pressure in the abandoned distribution main dropped to about 2. Okay, so when it did have a what did I just call it? Your meter has a baseline, a new zero meter, and the 0 meter is actually not zero. It would be this. As the pressure of the abandoned distribution main dropped to about 0.25 inches of water column, 1 psig, I'm sorry, 0.01 psig per square inch gas, the regulators responded by opening further, increasing pressure in the distribution system. So the regulators responded. So you have this vortex device that would measure that. It then tells it to open up the gates, if you will, to allow more pressure in. And that went down the pipelines, the new lines, went to the homes, as I said, and caused a failure in all those individual gas meter home meters. So much pressure that blew out the pilots. The gas built up inside the homes. Let's see if they get to that, because I did not read that yet. The regulators responded by opening further, increasing pressure in the distribution system. The regulators opened completely when they no longer sent system pressure, allowing the full flow of the high pressure gas to release into the distribution system, supplying the neighborhood. As a result, natural gas was delivered to customers at a pressure well above the maximum allowable operating pressure, which led to the ignition of fires and explosions in homes. It appears it has jumped to that point. Minutes before the fires and explosions occurred, the Columbia Gas Monitoring Center, they jumped to that. Wow, that's amazing. In response, 3 technicians were, let me just do something here. Let me jump a little bit. We'll come back to that paragraph. And I'm giving you this, guys. Let me just do this, because when you read out loud, sometimes I mess up words, and somebody trolled me on that. So let me not read out loud for a second. So they're saying they want professional engineers to be party to this whole thing, also, guys. That's not gonna, it's not gonna help anything. They need a proper checklist and etc. This is priceless here, and it's not in a good way. Right there. It shows you the quality of worker. Furthermore, the field engineer, they're calling him an engineer, not in a literal term, but as in I'm no offense, I'm a trash engineer. I work on the trash truck. Furthermore, the field engineer had limited knowledge about the importance of the regulator sensing lines or the consequences of losing the capability to sense the main pressure via the regulator sensing lines. This is just so this guy's the supervisor. It's just crazy that he knew nothing of it. So what did they send out there? Again, this is just negligence. So I don't know what's going to come of that. This will make my this is just that's just too much, guys. Hey, Embry, dead 60 main. Then yes, you can have more pressure, but flow has nothing. I know we talked about that before. Flow has nothing to do with it, Embry. I know you're a meter shop man, but you get rid of flow and you don't have any pressure anymore, right? I'm sorry, you do have pressure, Embry. So Embry, what I said earlier, is sort of stealing from Embry now, is that if your pipes don't have a leak in them, you're still gonna have pressure in the pipes. Like and Embry is saying, what he's saying, now if you're controlling the dead, and you still need flow, and he says, but flow has nothing to do with it. So Embry, I don't. We're talking. I'm reading Embry's comment, so there's nothing really I'm not sure what he means here, Embry, because flow definitely had something to do with this as far as the volume that caused all this. You need flow. Without flow, we don't have a problem. Embry, you just got status quo. So I'm not sure what you're doing with your flow in our conversation. The constructability over. Oh, wait a minute, I didn't put that over here. Furthermore, I didn't put the quotes proper. Hold on. Amber, you got to tell me what you mean there, buddy. Equals unqualified person for this job / task. All right. So no, the controller variable in pressure, not flow. Okay. I don't know if we're talking the same thing, Embry. This just sends a message. It's not opening up anything. It's just telling what's going on. And then the next device, whatever they come up with, opens up the flow. But let's go, or increases the flow, right? So back to this report. Okay, right. The meters and regulators departments in the land service department were not required to review the project. Okay. NTS believes a comprehensive constructability review would, okay, you're right, was right here, approved from a professional engineer, would likely have identified the emissions of the regulator sensing lines, thereby preventing the error that led to the accident. I don't believe that would resolve it. Just because you have a PE, I don't believe a PE would have known that, because first off, no offense to my other PEs here, is that most of them don't know how to talk to contractors. Again, that's that personality thing. They don't know how to be aggressive with contractors and workers and tell them what to expect. They're more observers, kind of, and I won't cross the line anymore on that, guys. And so they don't know how to say, look, you need to pay attention, stay focused, do this. That's the way I talk. They can't do that. Most of them, in fact, I've never seen another one do it. So they don't know how to say, no, you're doing that wrong. You need to, go get yourself certified, qualified. I'll bait you on all that and mean it. By sealing the project plans, sealing the plans. The PE takes responsibility for the accuracy and completeness of the engineering package. Well, yeah, but he doesn't take responsibility for the guy actually doing the work, not unless it's, part of is he the contractor? He's just laying out the system, how it should be done, the method. Neither the Commonwealth of Massachusetts nor the Colombian gas policy required a registered PA. Now, what are they doing here? They're deflecting. We should be talking about this person's not qualified, that Columbia Gas should have not had this person there. But now they're coming up with remember what I'll say, guys, what's that damn thing you're looking for? The magic balloon, the magic weight, the bird, the invisible bird. So now they made the invisible bird. NTSB, the invisible bird is the PE should have been made that would stop all of this. Not that Columbia Gas sent a man out there who had no idea what he was doing, as right here, had limited knowledge about the importance the regulators, sensing lines. He didn't have common sense. That's ridiculous. But now they make it. They found the bird, the invisible bird, and here's the invisible bird. This kills me. The invisible bird, for anybody watching, is the magical bird that if you could show that it landed on the bridge, it weighed, trillion tons, and it made the bridge collapse. So therefore, nobody's fault because, well, the invisible bird did it, and that's that. So I say the NTSB likes finding invisible birds, and here's their invisible bird on this one. Neither the Commonwealth nor of Massachusetts nor Columbia Gas policy required a registered PE, a magical bird, to develop or review public utility engineering plans. Oh, awesome. According to the National Society of Professional Engineers, now they're showing they're going the direction. I'm not going down that path. Here's a here's a magical bird, and why this magical bird should, it's deflection. Let's go and find back to the facts. The NTS believes that it is critical that an engineer with the appropriate qualification and experience review engineered plans. Again, they're blaming on the bird plans, not the actual guys in the field. If not, develop them to come up. Gosh. And I know they got to come up with a plan of action, right? But the plan of action should be, so what? He's an engineer. This guy is the problem, not this. The PE is a licensed regulatory environment. See how they keep going that line? Okay. Now we're talking about record keeping, everything but what happened so far. And that's at the top, one little sentence, I think, right? Okay, management of change. Columbia's Gas implementation of management of change, MOC. Okay. Is limited to the management of the distribution integrity management plan, DIMP, PIMP. Yeah, I just couldn't help that. The program required by, come on. I'm glad we only got one page of this left. NTB investigations also learned that until about 4 years ago, what the hell kind of talk is that? Sounds like me talking to a guy. Columbia Gas required that a technician monitor any gas main revision work which required depressurizing the main. That a technician, this is a huge word, right? It means, what's a technician? The technician, typically from the meter and regulation department, would use a gauge to monitor the pressure readings on the impacted main and would communicate directly with the crew making the change. Good. If a pressure anomaly occurred, the technician could quickly act to prevent an overpressure. So 4 years ago, they knew about this issue. Columbia Gas offered no explanation as to why this procedure was phased out. That's right there. That's priceless. That's what they should be attacking. Although the Columbia Gas Monitoring Center in Columbus, Ohio, received high pressure alarms and reported the event to the meter and regulatory departments 2 minutes after receiving the first alarm, there were no technicians pre-staged or positioned to immediately close valves when the okay, so that's the one that they notified them. Columbia actually had the overpressurization warning, saying it's too much there, and boom, and notified them. Now here you go. Columbia Gas adequately performed MOC and placed personnel at critical positions along the system. Columbia Gas could have immediately addressed the issue and mitigated the consequences of the event. Therefore, the NTSB recommends that NiSource apply management of change processes to all changes to adequately identify system threats that can result in a common mode failure. This is just vague as can be. Additionally, the NTSB recommends that NiSource develop and implement control procedures during modifications to gas mains to mitigate the risk identified. Gas main procedures should be continually monitored. They need to do it at the end user. They need to resolve this at the end user also, to see if the end user has got a surge, if they receive the surge of pressure and the pilot lights are going out. It shouldn't happen. You should not have a surge of pressure. You just can't have it. You're going to blow out pilot lights, yeah, whatever. Okay, so let's blow that off. Let's go to the top again, and I'll show you this. And scroll down. The project was to install a plastic distribution main and abandon in place the cast iron distribution main. The distribution main was abandoned, still had the regulatory sensing lines that were used to detect pressure in the distribution system and provide input to the regulators to control the system pressure. So as we go here, you see that this was still in line on the abandoned line, but yet it put input, as they say, to control the system to the regulators to the system. Now, I don't know, they must have walked away, but what they left off in here is the end failure, the end unit, the customer's failure on their side, how that took, what happened next, why the explosions inside the homes. They did not say a damn word about it. So that leads me again to that it's just nasty. NTSB, I think they're a piece of shit. So and here we go. We're going to go to 25. This shows where I said this. Their report already said it, but I also explained that this overpressure came in to the regulators of the homes, and I want to know how the regulators of the home made out. How did they fail? Came into the pressure regulators of the home, blowing out pilots, also increasing the amount of volume coming in there, blowing out regulators, and the building up, great amounts of gas inside the homes, oxygen saturation being equal, and 5 psi. G, that's right. Hey Tom, hey Rick. At half a psi, the supply pipe would be a huge diameter. Lights up a smoke. Robert lights up a smoke. Rick, could he have meant it cuts the pressure in half? I can't beat Rick. Hey Rick, I can't beat Embry. Embry kicked my butt. At time, very old neighborhood service. This was the perhaps 8-inch or 10-inch main. Okay, what we got here? Hey Ricky, what we got here? So the sensor was still hooked up to the removed pipe. Yes. And if you see here, I said this a long time ago, but I'm gonna hit 2 points here. 25, a couple points. 25 minutes is here. There's 27, 28, and 30, 40, 55, and 55. 57 also. Here we go. Sir, you're telling the regulator, if you were to cap this end and cap this end, what would this sensor tell the regulator to do? Remember, guys, I said this way before this report, September 16th. This was my theory that what if this sensor was still on an abandoned line, capped, what would this sensor tell the regulator to do? And that's what I said. So I called that, forever ago. Here we go, listen. Rick Hermit, you want another tip? You want another tip on this? Okay. I just showed you how the regulator works, right? And he stated how he theorized it works, but we're watching a video, guys. I'm not talking now. I'm talking in the video, but here we go. It's going to get to 25 seconds. I just wanted to back it up. 25 minutes here. Just backed it up. He's okay with that. Let's go with what he's saying there. We can make that work. So what do you know? They were working on a pipe. The sensor was connected to a pipe. They were disconnecting. What do you know about? Hermit says, I got it. Come on, Hermit, tell me. I don't want to give it away, guys. So what do you know? What would this sensor be telling the regulator if you were to cap this end and cap this end? What would this sensor tell the regulator to do? And there we go, guys. And you see me playing devil's advocate there, waiting for you guys to catch on in that video, what it would do. Well, it would tell it to increase flow. And I don't know if Embry's going to get upset again. It would tell it to increase flow. So, and this is exactly what happened as we read here. And provide input to the regulator to control the system pressure right here. Had the regulator lines that were used to detect pressure in the distribution on the abandoned line, it was still there. And the abandoned line in place cast iron, right? Inches of water column is the unit pressure measurement that is typical used for low pressure gases. As the pressure in the abandoned distribution main dropped to about 0.25 inches of water column, the regulators responded by opening further. Well, they were told to open further by whatever the flow meter they had, increasing pressure in the distribution system. I showed you a vortex meter in another video. This is a vortex. There we go. Let's see what I'm going to jump
What
to the
would
next
he
part.
do? Well, I would hope, here's the thing about it. I would hope there would be another regulator on here for the other sensor.
That's what I hope. There would have been another regulator on a new pipe, not recycling the old regulator. I mean, this old vortex meter. You know, maybe it's calibrated, but you know, give it a new one on the new line, then abandon this one, take it back to the shop, rework it, send it back to the manufacturer, and go again. A primary and a secondary. If they don't have a primary and secondary, if this one goes south, they're in the back in the same position again. All these systems, well, I'm going to say should have a primary and a secondary. They appear to only have a primary, and I sort of one system, one only, and I get triggered here. Let's see.
But it appears that both regulators are connected to the same sensor.
Which I'm confused. Oh, right. Two regulators, one, and let's move on.
This is what the problem is, I think. He's not letting on to that at all. But I'm thinking both regulators are connected to the same sensor, guys. There's only one damn sensor, both regulators. So there's redundancy in the regulators, but there's no redundancy in the sensors. So one sensor says no flow. It tells, and it's the capping off a pipe. It says to the regulator, we've got no flow, and it says no flow. Let's go ahead and increase some pressure. Although it should really theoretically, it should almost say, well, there's no demand. But it's reading the flow wrong or something. Somehow this is reading the flow wrong. And
my guess is because it says that zero metering I told you guys about. Zero metering is sort of like, imagine this. Instead of zero being okay, it needs a new zero. It would be like 0.5 would be a zero. And then a dead zero would be literally like a zero. And so when this saw a dead zero, because it probably a gas, leaking because these pipes leak, it said, oh, we need to increase the flow. And with the regulator, and there we have it. So let's go from there.
And it's saying we need more pressure to we need to open up the regulator because our demands, we're not doing anything.
It's going to keep asking for more until this reading goes up, and as long as that until it gets flow, and then so it starts reading. This vortex type meter would read, and since it's not reading anything, it's saying, oh, give us more flow. And it's like, what the hell? It's not working. They have no redundancy there. That's what I find amazing in this system, in their system. Doing anything. Somehow I don't know what kind of regulator you use. You saw the way this one works. But their regulator But you also see in their report, they ask for no redundancy in their system. They blame it all on the magic bird. The PE's got to come in there and save the day. That's the magic bird. Vortex meters, I call them, flow meter, Embry. Right. The capped line or abandoned line, if you will, said to give it more. Full steam ahead. Reading comments. Yes, Ricky, it was still hooked up to the abandoned, hooked up to the removed pipe. It's abandoned. They weren't going to remove it. They were taking it out of service. That would be removed, if you will. But it was still there. In other words, just run another pipe next to it. As far as I know, they run another pipe right down it. That's what I would do, right? Spiking it, what they used to call it back in the day, but they don't like spiking pipes anymore. Here we go. Their sensor told that regulator to open up more, increase the volume, and it still couldn't get a reading. So I theorize now, that it just said, what the fuck, man? Let's just blast this shit out. We need more and more and more and more. Wow, I guess I cursed on that one. That's what the thing said. And so here we go. People down here are running everything like the wintertime or something like that. But here's my catch-22 of that. If there's a broken gas pipe down there, right? This flow is amazing. And so your broken gas pipe would actually demand more flow to feed the broken gas pipe. And again, there would be another, you could make the problem happen again. But here we go. But then the one in, to be able to regulate it, then let's go on. That's the way these things go until you shut them off. But 27, 22 is my next statement. Depends how they connect it.
That's a flow meter. Open the regulator that was in service. Well, it's getting I think they're meeting the same one. They're missing crucial details like a pipe. Yeah, that's true, Embry. But here we go.
I'll repeat that. We found evidence from the evidentiary dig this morning that pressure sensors were attached to a gas line that was being placed out of service and being capped off on Thursday.
So they don't ask it in the audience, but I would have said, wait a minute. So they were connected, but was it functional? So what? It was connected. Was it?
If you guys remember this video, this is what I commented on, saying, hey, I want to know if it's connected. And then we're talking about that meter. I want to know if this was connected. Was it functional? It says it was connected. Was it functional? And it turns out, look at my bottom, my screen, my little mouse. You see that's the meter. I want to know if it's functional. It turns out, but nobody knew to ask that. It was functional, and here's the end result.
Was it functional? Don't leave me, because I'm making this video. So on the flip side of that, also, me guys, I always open for data. Flip side of that, I'm like, well, so what was connected? Was it functional?
And it turns out it
and
was.
He doesn't state that.
He could have stated that in this release. I don't like Grimwald. This guy's just, they're so devious. NTSB is not forthcoming because he knew it was functional then. He could have said it, but no, he's going to leave that out. You see the report, how nasty that report is looking for the visible man instead of calling it where it is. So this NTSB is so damn political. They're not neutral because it's just nasty.
Certainly the investigation will answer two questions. What effect, if any,
flow itself says nothing about pressure.
Let's go to 28. 28, 25.
And secondly, why was this sensor connected to a gas line that was being placed out of service?
Right. Why was it connected?
Okay, so they want to know that. But Jenny didn't say whether their sensor was functional. So what it was connected. So I need to know the extra detail of that. But let's go on.
It's 7 blocks away at South Union and Salem Streets.
So 7 blocks away where they capping this. This guy friggin' triggers me.
Triggers me, yeah.
And I certainly want to thank the state for their doing this tedious but very important work.
Well, two more.
Now, many of you want to know if it's safe to return to your home.
That's the wrap of that. He's just going to yabber on. You ever play with adding too much gas to one and watch it blow through?
That was Embry. Me playing with Embry, and that's it. So that's the end of that one. So there we have it. And what we got here? Ignition would depend on gas concentration. That's correct. Like air gas in a car engine, 100% correct. So yes, there we have. So he mentioned nothing in this report of how on the home explosions. So they mentioned this one thing that I've already said happened a long time ago, but they mentioned nothing on how the homes blew up, on the concentration, as you said, and that's nasty. They went all over the place, talking about now they need to hire a PA, and this company no longer monitors when they're changing out, and it's just nasty. So this is what I think of the NTSB. They're just piece of work. They're a piece of work, and you guys see the latest? I'll do a video on that latest on that darn P 2015 sent me a link on the latest for the bridge, FIU bridge thing. Looked at it a little bit last night. I've been still searching for stuff. There's nothing terrible yet there. But just that article was again leaning back towards number 12 and number 11 basically again. That's just another thing that but it couldn't take the loads. Well, that's a good vague way to say loads. I mean but to design it, but it was nothing to do with number 11, 12. Number 11, 12, it couldn't. Of course, anything fails, you can say it didn't take the load. it was under tension, but they're still looting. It seems like they're going to try to imply it's under compression. That's just a lie, just like this is a deceiving lie about about the way they did this. All right, so that's it. That's it on that. This is the gas update. This is the gas update. Well, and I'll do that update on that maybe later tonight on the let me get rid of that. Later tonight on, get out of there. On the bridge one. Flow, noun, steady continuous stream of something, gas in this case. Thanks, Duds. Thanks. Yeah. Embry doesn't like that though, Duds. You're triggering Embry. You're triggering Embry. Flow. Pressure. Why you want me to keep saying pressure, huh, Embry? Pressure was created by the flow, by the gate opening, and not being able to make its way out on the other end of it. Out of all the, being able to make its way out of the other end inside the homes, coming out so much, blowing past these regulators, these home regulators, and allowing a huge amount of flow because of the pressure. How's that, Embry? What's up with you, Embry, with the flow and pressure? I'm with Duds now. You're gonna lose this one. Duds is my man now. I thought about your car, Embry, your hot rod. Embry's got a hot rod. Yeah, I just make him give it up to us. Similar term, he was too dumb to know he did something wrong. Yeah, but it wasn't his fault. He wasn't too well. I mean, if we're talking about that one guy. You know, it'd be nice. You know, if they want to protect this line, they would first put on the meter on the new pipe before they connect it. But they appear as they only have one. They don't have two. That's what I find amazing. They're not cheap. I mean, they're like $30,000, but really, you know, it's cheaper than blowing up homes and guessing the way their system of a guy being here and monitoring the volume on this end. I think that's ridiculous, having a manual guy there. I mean, sure, to turn it off if something goes south, but you should not be doing it from there. You should use the meters again. That's what you're going to depend on ultimately anyway. So if I'm going to depend on those meters, why am I using a third person that I have to use a speaker to communicate with? I should be able to shut that down immediately. Well, of course, this was 7 blocks away, as you saw when I commented on when I showed that at 55 minutes. It was 7 blocks away. So you do have that's a detail because you'd have to have a plan B if I need you to shut off the main gas 7 blocks away. I'm talking to you on the phone. Hopefully I'll have 2 of you guys on the phone, you know, walkie-talkie or something, which then we don't worry about, you know, the electronic sources by gas. But you want to at least be able to have 2 ways of communicating with the person you need to shut that gas off with. And also 2 men there, or 2 people rather, and to be able to shut that gas off, not one. You need redundancy. All right. Yeah, I think it's just cutting corners, as this report shows, where they dropped it, where they no longer use that system that they had that apparently worked. And now they're blaming the magical bird, the PE license guy that doesn't even exist here, that would have saved the day in this whole project. When they never said that PE has to be out there at the job site worrying about losing his license. They just say you got to draw up plans and systems. That doesn't, his license still protected. If they did use a PE to do all that, he says make sure you move the meter over first or last, or make sure you don't turn the gas on until you switch it over. They wanted to do this live without having to go to, you know, thousands of customers and change their light all the pilots up. They wanted to do it live, and they did it live, and then they blew up all those homes, right? So the homes didn't blow up because of the ignition source, the gas source building up, and as this one person here states, that one person, you need the right air pressure. I mean, oxygen levels, saturation. So that's it. The local distribution main was all mechanical. The mains, yeah, I don't know 100% details of that. Not that it matters to me. What matters to me is, again, their system, which I already called out on. I don't care for how it was piped. I mean, how That doesn't matter. Are you saying you using Grimoire to validate you, Embry? You lost 10 points, man. You lost 10 cool points using Grimoire to validate anything you're saying. You lost some cool points. You only get 10, and you just lost 9. You leave you 1. All right, so that's where we are on that, guys. So let's keep that video there unless somebody else is saying something. There's the link here to the report. Let me confirm it works. Yep, there's your link to your report. You can read it. You can call it whatever. It's the urgent review. It says ongoing investigation, just so you know. They're not explaining the inside of the homes. Who knows? I think they do these reports to see what kind of act they do, the monitoring of the press and things like that, to see what they're going to go after. And when they see that they don't know where they're going, then they just say, well, let's just double down on what we got here and just call it a day. We won't do anything else. Let's see if we can get away blaming professional engineers for this problem. Really? Because I didn't see, if the press, reminds me of the feminists that says that this guy I'm fighting with on Twitter the other day was saying that, and he calls himself a life coach, that the absentee dads are causing these problems in these families. And I'm saying, do you realize you just said that the guy's absent and you're saying he's causing problems in the family? Well, first off, the mothers kick him out, right? We pretty much know that, but he's absent. They're blaming this gas explosion on an absent professional engineer report. I mean, a schedule, if you will, on how to, well, I don't know if that would be, if they were forcing that guy to do that, or girl to force him to do every single detail of how to transfer it over. But they're blaming it on the absentee dad. This is the guy that's not present. So it would be nice if Peas could stick together and tell Grimoire, you're full of shit. You know, well, this is nasty. I don't know why they would do that, and why the other Peas at Grimoire's behest would not fight this. This is nasty. You know, that's nasty. They'd have to be in the field, totally responsible for the job. And that's the size of that. And then what? So what? It still doesn't resolve anything. He can still make the same mistake. You just resolve it. All right. That's it. I'm going over here. DOS just stepped in. I'll give a second. DOS. Hey, Gordon's gone. Okay. Yeah, Gordon there. So that's it. Catch you guys on the on an update on the like I said, the what did my man send me? Let's see if I can quickly find it. NTSB one, this one. Let's jump over here and see if I'll click it on it real quick. It's right here. I'll come back to this later tonight, but this is the Miami Herald's version, and if you go to the page report, Miami Herald's trash, so I don't bother their version of it, because remember, they don't release all their information they're getting. But now we have the same information, the Freedom of Information Act that I have the same information that they have, so they don't have anything special. But here's a nothing little report. But I think, again, it's just being sneaky. It's nothing really here. It's nothing really here. It's nothing special. They're back to this. Besides, I guess I'll do a little hit of it right now. The number 7 bars. Collapse-induced deformation of the size number 7 bars precluded their testing. Well, that does not preclude their testing. Collapse-induced deformation of the size number 7 bars precluded their testing. That's again stupid. That is data. You still can test the bars even deformed. You need a section of the bar. You know, you'd have to grab a bar and roll it all the way around to 0. I mean, roll it in circles for it not to be able to be tested. So you just got to find out. I'll do the video on it, but imagine if you can't test a bar that's been bent, right? It has tension on the outside, compression on the inside. But at some point, it's going back to a straight plane again. That point of the margin of safety beyond those point, that bar at that point is testable, if you will. Now, if the bar was bent by like a fulcrum on the far end, it's again it's the same way into it, but it's still rebound plastic, so you can still use it. So there's number 7 bar is very critical that I have to spend some time finding in the plans where the number 7 bars are. You just told me that they're actually, I need to know where they are, where these 7/8 inch bars are located. That is interesting. Tension tests resulted from the remaining bars found that all met the minimum yield strength, tensile strength, and percent elongation. And I'm just going to dive on this a little bit for you guys. Is that wherever the 7 bars, were the only number 7 bars there? What else was crisscrossing the number 7 bars? And they're making it allude that everything else that touched the 7 bars was okay. But number 7 bars being by themselves, isolated, are not okay. I'm guessing number 7 bars, guys, are down the column, and that it's got data in it, because the bars, guys, if you are going to take this apart through forensically, the bars are going to tell you exactly what's going on in the moment in the concrete. You can't flex concrete too much without bending the bars. Once you bend the bars, if I have a bar and it's bent here, guys, like this, we know to bend that bar like that, I had to bend the 2 ends. You can learn a lot by the bend, the remaining bar. You show me a hook bar like that, I know you held it on one end, bent it on the other. I can determine if you bent it from both ends. This is nasty. So I'll get to that long spiel another time. Yeah, okay, cool, Ricky. But that's it. Let me see if you guys got a comment on that. That is not, whoops. That's Ricky. Over there. They come here. I looked at the wrong one. And over here. Right. So that's that one. And where are you guys? I think I lost you guys. I think I jumped out of here by mistake. That's on mute. And let's see what you guys got. Yep. Yeah, I agree. I agree. I totally messed that wording up. All right, guys, I'll catch you. I'll do it tonight. I'll do another video on that release. And kind of odd though. I have to figure out how to do the bar thing. I think I'll do. Let me just write my notes here. I think I'll use a hanger to try to show you. I have to find a metal hanger. Anyway, got to go pick up my boss. We know who the boss is. All right, hanging up with you guys. Hanging up somewhere. Take care. Thanks for watching. Catch you.